Let's try again. Right, so I've got the recording going as well. So let's start off. So IDEs, independent development environments. Way back when, coding used to be done and required at least 2, potentially 3 programs to be able to actually complete the writing of the program with the code. You needed a text editor, which was usually something like Notepad or Notepad++ when we got a little bit more advanced. And then you needed a separate program that would compile the code that you've written and turn it into an actual program. Some of the compilers came with built-in security certificates, but not all of them did. So on some occasions, you also had to have a third program that would sign all of the security stuff for installing programs onto different operating systems. Excuse me. The IDE, some brainiac somewhere looked at the fact that they're using like 2-3 pieces of software and went, why on this earth are we using this many pieces of software? We write the software, let's just write everything into one program. So they did. They wrote everything into one program. And we've got quite a few different options, but the main one that we got and that's still around is Microsoft Visual Studio. So in Visual Studio, we've got our main window in which we write all the code. And let me just reset this to default state. Now this is just an example of code. For some reason, the C# packages aren't installed on this computer, and it's a college computer, so I can't go through and install them myself. My computer is off having its sound fixed. Seeing as how I checked and did everything I could possibly do to fix it myself, so it's gone back to have the sound fixed by the people who made it. So this doesn't have the C# stuff, so we're not worried about the programming language today. Anyway, but we've got this edit screen. Now, in the edit screen, that's where we type all the code. This screen here is the equivalent of what would have been Notepad++. We've then got build options. And we can build the code and compile the code ready to publish as a program. And when we talk about compiling code, what we're actually talking about is taking the language that we've written the code in and turning it into a more basic computer language for the computers to read and be able to execute. So it turns it into usually 1s and 0s, which is binary, which is computer language. Once upon a time, all computer programs were coded in binary. And then we got better, and now we don't necessarily need to code it. Some people still code in binary, but we don't need to write programs in binary anymore, thankfully. So it does the compile. It also has an option in one of the settings for security. And depending on what bits have been installed, you can actually attach security certificates to the programs in the IDEs as well. Only I can't show you that on this one because that has also not been installed. Yay! I do love having tech issues. Now, aside from making it so that we don't need to use 2 or 3 different programs to write the code to make a program, IDEs have also allowed for us to have additional tools at our disposal and additional supports at our disposal. So IDEs allow us to access things like general common libraries of code. And we can import these libraries and we can include them usually at the top of the code file. Now, this is not a C# file. C# not installed. But in C, this is C++. So in C++, we use include. In C# we would put using, and then it would actually link to the different files that we are using. And if we look over on this left-hand side, you can actually see the two code files in there as well. So we can use pre-built libraries, and we can link the pre-built libraries fairly easily using an IDE. IDEs also allow us to highlight errors. So if I forgot to put a semicolon at the end of this line of code, it gives me the red squiggle error. It highlights the code. And if I've got the error window showing, it also tells me what I've done and what I've missed in the error. Hi, Declan. We're just looking at IDEs at the moment. All of the information is up on Teams anyway. So I'm just going through, adding to it and elaborating on bits and pieces. We can double click it and it will take us to where the error is. We can hover over the error and it will say what is expected. And then when we put the missing bit back in or we fix the problem, the errors disappear. So it gives us easy access to finding where errors are. It color codes code for us as well. So in this particular example, which is not the best example and not one that I would have chosen to use, but anything that's commented out is green. So anything that is not being read by the program is colored green. Anything that is some kind of string is colored that strange reddy, browny, orangey color. I don't even know what color that is. Data types are colored blue. If we had a piece of code that's called, say, the main method here, any other instances of that would appear highlighted or in a different color, in the same color, and they would highlight as you go through the text. You can collapse bits of code. So if you're working on a program, you're working on a particular part of the program, you can collapse everything around it. So if you've got a program that you have to scroll forever to get to the bottom of or to get the bit you're working on, you can collapse blocks of code so that the only bit that's open is the bit that you are working on. It gives you tools for doing things like commenting out lines. So if you want to check to see where an error is coming from, and you want to see if it's in this particular piece of code that's throwing the error, you can comment out all that code with one click of a button. You can reinstate the code with a click of a button. So it does a lot of stuff to help out with that. It also has the Intellisense option as well. So if I was to start typing string, or if I start typing something that would actually exist or be used in C#, in C++, it gives you this drop down, and it will let you pick up from the available options that match what you've typed. Although string apparently doesn't exist in this particular C++ thing. I have no idea what's going on. I don't code in C++, as you might have gathered. But you get the Intellisense, you get this drop down happening that you can select from. It also automatically indents the code. So if I take that back out and we go back to there, if I press enter, the code is automatically indented. If I do an if statement, and I press enter, that will automatically indent the code. If I put enter there, it will line the code up. Now, obviously, it's throwing a shed load of errors because that's not code. that's me hitting keys. But it indents the code. It also gives you these nice dotted lines, so you can follow what's linked to what just by following these dotted lines. You can collapse within parts of code. So if I needed to continue after that if statement, but I had quite a lot of stuff in that if statement, I can collapse that sub piece of code instead of just the main piece of code. So it allows us to collapse code. And it allows us to automatically indent code. And the last bit that it does in terms of supporting tools is it makes it easy to move around what we have in our programs. So we've got this solution explorer over here. So when we're writing a program, it's called a solution in Visual Studio. And you've already seen I can click and move between these two documents. I can right click on a file. I can remove the file. I can right click and I can, somewhere in here usually, somewhere in here there's a button that lets me add. Oh, there we go. New solution to this Explorer view. So, no, that's not it. Oh, there we go. Add existing item. And then I could go through and I could actually add that code back into my solution. So we can easily amend, change, add to, take away from the solution that we're using. We can also exclude solutions from a problem. So I can exclude that, and that will still be sitting in a list somewhere, and then I'll be able to bring that back in. So we've got the Solution Explorer, which allows us to easily manipulate the code. The notes upon that are all on Teams under Unit 6.15 Independent Development Environments, funnily enough. So does anyone have any questions on IDEs? If you do, post them in the chat. If you think you're happy with the idea of IDEs, put your hands up. Let's see if putting your hands up actually works today as well. Oh, it's working. Excellent. That's good. Obviously, Jack has no audio, so Jack won't know that I've asked a question, and Declan's having bad internet. Arthur, ask me that at the end of the session. It might be the case that you. I'll tell you what, Arthur. Get a share link. Put it on OneDrive. Get a share link to it from OneDrive. Put the share link into a Word document and upload the Word document with the share link. I can do it that way. Right. So that's IDEs. Next bit that we want to look at are the different types of language. Now, according to the spec, there are 3 different types of language. I actually recognize 4 different types of language. So you've got your high-level coding, which is using an IDE to type the code in. That's what we've been doing. Now, I refer to that as pure coding because it's not visual. It doesn't have nice, pretty elements to it. It's just text. So I include a pure coding in that, where we write everything in the language and we type it all out. Then we have the visual languages, which are drag and drop for a graphics built editor. Please note, Visual Basic is not a type of visual programming language. It is a Visual Basic is usually used either in pure coding or in scripting, which we'll come to in a minute. Visual languages. Has anyone used Scratch or GameMaker? Put your hands up if you've used Scratch or GameMaker before. Also put that in the chat for anyone who's not seen this. So Scratch and GameMaker use a visual type language. And if I go to this version of GameMaker that I have open, and we just ignore what's there, that's for level 2. And I open up this bit, and we can add something in there so we can add code to it, otherwise it gives me an error. So this is a visual programming language. And it's visual because we can do things like we can drag stuff in, and we can set a direction, we can set a speed, and it gives us essentially a graphical representation. It's got code in there. We can ask it questions. So we can check for a collision at a particular point. If there is a collision, we can do a start end of a block. And in the start end of a block, we can put in things like change direction, and we can drag that in. We could tell it to jump from one place to another. So it can jump back to the start position. We can tell it to do some sort of weird bounce thing. And we could go back and we could do an else statement in there. And we could do the same thing. Not that you would ever do an else with exit this event, but that'll be a bit strange. But that is a visual language. Scratch works in much the same way for people who've used Scratch. And it looks different. It's actually probably slightly more visual, but it's essentially the same thing. You get the events that go in, you've got your controls, you've got what happens, you've got repeats, you've got if statements, you've got questions that go in there, and it's the same idea. So that's your visual programming languages. Now, most of these, where you get this sort of drag and drop interface, are built on a particular language, or built around a particular language with a particular programming paradigm. I think, although GameMaker has its own language, I think the GameMaker language was built on top of, what was it built on top of? Oh, okay. Mind blank, I'll come back to that. But they are built on top of other languages. So they have a language that they use as a base, whether it's C#, C++, Ruby, Perl, Visual Basic, Java, JavaScript, and so on. But some programs also have their own types of code as well. So GameMaker actually uses its own variation of a language, which it's called GameMaker language, because using an existing language makes no sense. So that's visual languages. The next type of language is scripting. And scripting is where we can add in bits of code to something that is either more visual, or in the case of games development, it's the code that we can add in that allows us to actually code the game. And what happens with scripting is you will drag a piece of code in, or you would you create an object that has code, and it usually will take you to some kind of IDE. Now, GameMaker has its own little IDE built in. Something like Unity will load Visual Studio. I think Unreal Engine goes to Visual Studio as well, or it will go to whatever IDE you tell it to go to. And from there, you can type in the code, you can indent the code, same as you would have on any other IDE. Now, obviously, that's just like me showing you where the text would go in there. And that will actually then input that piece of code that you've written into your program. And then when you were to, if you were to then compile the program and run the program, that piece of code would still be sat there, in addition to anything else that you happen to have in there. So in the case of GameMaker, you can add additional code of your own devising into the pre-built code that you can add with the drag and drop. So that gives you scripting. The final bit is markup languages. Now, markup languages tend to not create a program on their own. You tend to need another program to interpret the markup languages. The most common place to find markup languages is on the web. Most of the coding that is done for the web is based on markup languages. You can't create, or well, you certainly couldn't create, I haven't checked recently, but it's unlikely that you could create a standalone program that you could run from a desktop built in HTML, CSS, JavaScript, PHP, and MySQL. They need a browser to interpret what is being written. And that's what makes languages like HTML, CSS different from other programming languages. They are also technically classed as a script because they're individual portions that get put together into the browser. But they are more a markup language that tells the browser what to display. So markup languages need another program to be able to interpret them. And there is a little bit of a clue in the full name of HTML. So HTML is an abbreviation for Hypertext Markup Language. So they have their own coding languages, but they usually require a separate program to run, which in the case of ones that are mostly seen on the web is a browser. So Internet Explorer, Microsoft Edge, Chrome, Firefox, Safari, Opera. God knows how many other ones are actually out there now that I can't even think of off the top of my head. So those are the types of language. Anyone have any questions about types of language? Or if you're happy with the type of language, put your hand up. Excuse me for a sec, guys. Oh, right, I'm back. Sorry about that, guys. I've got some doctor's surgery, which I needed to answer to tell them, ask them to call me back later. Okay, so yeah, we're all happy with those bits. So now we're going to get to the bit that I'm going to make you guys look at. And excuse me, I'm not doing well this morning. And that is the reasons for the choice of language. So there's a number of reasons why a company would, or an individual for that matter, would pick a particular type of programming language or particular programming language to use. So we've got things like organizational policy. So the organization says, we code in this language. Suitability in terms of available features and tools. So does the programming language have the tools for what it is I want to do with it? And does it have enough features to make it worth actually attempting to write the program I want to write in that language? Availability of trained staff. Do I have staff that can actually code in this language? Or am I going to have to train people? The reliability of the language, so how well the language has sort of passed the test of time. Is it still usable? Is it still being developed? Is it a language that, after maybe a couple of updates, starts to break down? How much is it going to cost for me to get this app developed? How much is it going to cost me to get an environment where I can actually create the applications? How much is it going to cost me to maintain the applications? Are there new releases to the language? That also needs to look at the cost of maybe hiring developers and maintaining it in-house, or developing something in-house and then hiring someone to maintain the cost, and the cost of the editor environments. So we can get personal licenses for Visual Studio, which allow us to use it independently at home for free. But if we were a business, we would have to pay for enterprise licenses. And the expandability. How much are we able to actually add into this program? How much new stuff can we make before the code starts breaking down? So that is a very brief overview of the reasons for the choice of language. So what I want you to do, I want you to look at the reasons for the choice of language, say why those things are a consideration. And I'll put the actual questions up in the chat as soon as I've nicked the questions from yesterday's lesson when I did this. That way I make sure I've actually got the right questions for you. I will at some point also take this off Unit 18 so that you've got, that's not the right one, I want this one, so that you've got the right question. Here we go. So consider the factors that affect the choice of programming language, give reasons why these factors are important to consider. And I'm just going to copy up the bit from the spec. And I want you to have a look at writing up, or finish off writing up the programming paradigms, add in the stuff about the IDE, and write up the types of languages. Do it all in one document. Okay. And put it all in one document, and that will make up tasks 1 and 2 of the assignment at the same time. Let's just get rid of all the random crap that's in this. Okay, so there's your instructions. The instructions are in the chat to work off. In case anyone wants to check back to them, you've got the 2 pages that I've put up. I've given you a brief overview of reasons for the choice of language. You guys are going to research that and write that up based on your research in addition to what I've told you. And you can finish writing up the programming paradigms, adding the IDEs to the programming paradigms, and writing up the types of languages. If anyone has any questions at any point, put the questions in the chat. Failing that, let's get on and get this work done, please, guys.